going to talk about finding hope and purpose. Who's hopeful about the future? Who feels optimistic about our opportunities and abilities to, tackle climate change? Who doesn't feel like that? Who feels somewhat worried or pessimistic or depressed or... Okay, so in the next 30 minutes or so, hopefully there'll be more of the former hands and fewer of the latter hands. This is a version of a talk I gave to some of my students who were complaining, quite rightly, that I was depressing them because I just talk about the end of the world, which is what I do for my day job. So I'm going to give you some bits of the climate science. I can't give you all of it, and to be honest, some of it is quite frightening. It's quite depressing, but that's not the entire story. So we can't just fixate on different elements of the climate crisis, because the climate crisis pretty much encompasses everything. It's not really a scientific or an engineering problem. It's a social, political, economic problem, and hopefully I'm going to give us a sufficiently broad overview that we can find some kind of hope. But let's start with the basics. Let's start with the physics, I suppose. Here's a nice little video. These are lines of latitude on the Earth's surface. There's the South Pole, there's the equator, there's the North Pole. And this axis running up along the side here, don't even know if the pointer's working anymore. This one up here is parts per million, so that's concentrations of carbon dioxide. These little dots correspond to those dots up on their map. They are research stations, and what they're doing, they're monitoring the concentrations of carbon dioxide in the air in real time. This red one's the important one. That's a research station operated by the United States Geological Service on top of an extinct volcano, Mauna Loa. And since the late 1950s, that's been directly monitoring CO2. And you can see in 1979, it was registering 336 parts per million. Now, as the years go by, we're now in 2005 already, you will see a number of things happening. CO2 goes up and down. It goes up in the Northern Hemisphere winter, and it goes down in the Northern Hemisphere summer, because in the summer, when the trees grow the leaves and the flowers bloom, they suck in carbon dioxide from the atmosphere. In the autumn and the winter, when the trees drop their leaves and the vegetation dies back, all that carbon goes back out into the atmosphere. So this is literally the biosphere breathing. Now, all things being equal, the amount of carbon that it breathes in will be the same that it breathes out. But you can see on this chart here, all things are not equal. There is a clearly increasing trend, and that increasing trend is entirely driven by us, by our combustion of fossil fuels and also our land use change. And if we can go back before the 1970s, this is the famous start of the Keeling curve in the late 1950s, and we can go back even further. We can use proxy records. If you go to the Greenland ice sheet or Antarctic ice sheet, you will find ice that is kilometers thick, that's been deposited over millions of years, some of it. You take a core of that ice and you can retrieve tiny bubbles of air, and in that you can reconstruct past climate. You can go back hundreds, if not millions of years now, and now we're in the realm of the great ice ages, these massive changes, 20, 30, 40 meter sea level rise. Global average changes of about 5 degrees Celsius between the bottom and the top of these glacial maximums and glacial minimums. So the story here is, yes, the climate has always changed, but what we've done in as little as 200 years is, geologically speaking, instantaneous, and we are beginning to see the consequences of that, and some of the consequences have yet to even play out. What's driving it? Well, we're driving it. This is a beautiful, in a kind of creepy and unsettling way, visualization of emissions of carbon dioxide. So this is the products of a very high resolution, essentially climate model, that's showing points of CO2 emissions in real time. And you can see the resolution is such that they're even getting down to individual power stations. So they're seeing the plumes of CO2 coming out of a coal-fired power station. And the story that this video shows is that it doesn't really matter where we put carbon dioxide into the atmosphere. It very quickly becomes mixed, becomes globally mixed, and it stays in the atmosphere for a very long time. The good news, if we stopped all burning of fossil fuels tomorrow, then natural geological processes would remove that carbon dioxide from the atmosphere. The bad news, that's going to take about 100,000 years. So essentially, the carbon that we put into the air is going to stay there forever over human timescales. The other thing that this video really shows is the natural pulses. So during the day, vegetation is drawing down carbon dioxide. You can see that in the great rainforest regions in Asia, in sub-Saharan Africa, and then also in the Amazon rainforest region, that kind of natural cycle on a daily cycle mirrors that kind of longer annual cycle. But what we've done through the burning of fossil fuels, we've put those cycles out of balance. There's too much carbon dioxide coming into the atmosphere because we've essentially been digging up fossilized carbon in the form of coal, oil, and gas. That's had an effect. This is a visualization of the kind of the climate stripes. So my title slide was that famous climate stripes that shows warming and graduated differences in color. This is another way of visualizing the increase in temperatures since certainly pre-industrial periods. And you can see that the later years are warmer, and there is also increasing evidence that rate of warming is accelerating. And this is a lovely way to actually visualize those kind of climate stripes. But that doesn't tell the whole story, of course. 1 degrees, 1.2, we're about 1.4 degrees Celsius of long-time warming, masks massive changes, very large regional changes, because the land has been warming much faster, twice as fast as the ocean, and some regions of the land have been warming even faster than that. So one of the warmest, in fact, the warmest continent in terms of acceleration warming is Europe itself, for a number of very interesting reasons. But the region that's undertaking the most warming is up high in the Arctic as a process called Arctic amplification. There we've got rates of warming 4, 5, 6, 7 times faster than that global average. Now, we have known for a long time that climate change represents a whole series of threats. The temperature increase is really just a very, very crude measure of the extra energy in the climate system, right? That extra energy is being used to generate stronger winds, more destructive storms. It's moving more moisture from the seas, putting in the atmosphere, therefore we get more devastating floods. It will produce more chronic droughts. It increases hazards and dangers, and we have for a long time in the political sphere been arguing about what is an acceptable amount of climate change. You go back far enough, it would have been 350 parts per million or 1 degree Celsius. It took about 20, 30 years of climate diplomacy into 2015 for the international community to agree for the first time that it should do whatever it needs to do to limit warming to no more than well below 2 degrees Celsius, right? And since, I would argue, 2021, that's come to be understood as 1.5. So has anybody heard 1.5 to stay alive? Or this kind of, that's where this understanding comes from. Now, initially, it was seen, and it is actually, a victory of those most exposed to climate change, low-lying island nation states, people who live in developing regions near the sea. Above 1.5 degrees Celsius, they literally won't be able to live there anymore as a consequence of sea level rise. But some of the science on tipping points that I'm going to briefly discuss is making it even clearer that 1.5 isn't really safe at all. So we really should be trying to do everything we can to limit warming as close to 1.5. Well, the bad news is, in terms of actual annual temperatures, we've already exceeded 1.5. Last year was about 1.6 degrees Celsius. This year is not going to be as warm, but it's still probably going to be above 1.5. And maybe in a few years that increase might not be as large, but I don't think really there's much debate anymore that 1.5 long-term warming is gone. And the reason I can say that is because if you want to limit warming to no more than 1.5, there's a certain amount of carbon you can put into the atmosphere. We called it the carbon budget. It's kind of like how much carbon you could spend. If we had have started back in 2000, we could have decarbonised at a rate of about 4% a year. We could have progressively and kind of gradually weaned ourselves off of fossil fuels such that by the end of the century, we would have reached net zero and we would have limited warming to well below 2 degrees. Obviously, if you start later, then you have to work harder. It's a bit like when you say you're going to go to the gym, right, on the 1st of January, but maybe you're going the 2nd, maybe you're going the 3rd. The longer that you leave it, the more work you need to do. Well, pretty much soon, around about now, if you don't actually start to phase out fossil fuels, then really there won't be any budget left. That was the good news. The bad news is the budget's been revised since then. Even now, just for a 50% chance, we think there might even be as little as 100 billion tonnes of carbon remaining in that budget. Annual emissions are order of about 40 billion tonnes. We might have as little as 2 years before the carbon budget for 1.5 is gone. So how can 1.5 be still alive? That's because policymakers will say that what we're going to do is we're going to continue to burn fossil fuels, that's that brown shaded area there, but at the same time, not just yet, but just in the near future, we're going to start to increase greenhouse gas emission reductions. We're actually going to start taking carbon dioxide out of the atmosphere. So if you can take it out of the atmosphere, then that can essentially extend your budget. So it's this solid black line which policymakers are claiming that we're going to be able to take in order to avoid warming beyond 1.5. Unfortunately, those technologies do not currently exist. There are some demonstrators, there are some projects that have been used to proposed ways to undertake large-scale carbon removal. They have all essentially failed, or they've been very expensive, they're very difficult to develop, and that's why I'm extremely skeptical about our abilities to do anything like that. In my opinion, if we hit 1.5, we're going to be at 1.5 for the foreseeable future. So yes, this idea that 1.5 now relies on recovery from overshoot, well, it always really did. Even worse is when you talk to very clever people, some of the climate scientists who've contributed to the IPCC reports, their assessment of where we probably might end up around the end of the century is more like 3 degrees Celsius. Now here, you have to hope that they are wrong, because 3 degrees Celsius of warming by the end of the century is potentially catastrophic. One reason it's potentially catastrophic is our understanding of tipping points is increasing rapidly. So next week, we've got the Global Tipping Points Conference, where the great and the good are going to gather in Exeter, and we're going to talk about how the Earth system is responding to the forcing that we're producing. And what's not good is that the more that we look into tipping points, the worse it kind of seems. It looks as if the more we go beyond 1.5, the greater the chance of activating a number of these tipping points. So I'll just give you some examples. Warm water coral reefs, they're pretty much gone. Warming above 1.5 degrees really does produce a very bleak outlook for warm water or tropical coral reefs, such that by the time you get to about 2 degrees Celsius, over 99% of these ecosystems are dead. We've got increasing concerns around the instability of Greenland and the western Antarctic ice sheet. Above 1.5 and 2 degrees Celsius, those things will perhaps undergo unavoidable disintegration. The good news is that will probably take hundreds, if not thousands of years. But when, I would imagine, one of the topics for next week, one of the hot topics, is going to be this kind of pink worm down the middle. This is the representation of ocean currents. The Atlantic meridional overturning circulation, it's a bistable system. It's responsible for transporting vast amounts of heat up from the equator. It's one of the reasons why, what's the primary reason why we have in the British Isles such a mild climate. We don't have anything like continental winters. We have very damp summers. Well, that is in the process of slowing down. Everybody accepts it is actually slowing down. And if we are unlucky, if warming does exceed maybe 2 degrees Celsius, then there's potential for that to rapidly switch off. That could actually lead to a significant reduction in temperatures in the winter in the British Isles, but more importantly, a large-scale disruption of precipitation. Basically, you don't run the farming systems that you used to do in the British Isles, over significant regions of Europe and also North America. It is the tipping point that must be avoided at all costs. Well, the good news is that's not all we're doing to pick up the Earth system. We're also undertaking one of the great mass extinction events in the history of life on Earth. That's largely the consequence of the land use change that we've put in place, large-scale deforestation, and the disruption of our hydrological cycles. And we have political headwinds. It's not as if we are actually putting our foot down on the gas and accelerating climate action. We now have a president installed in the United States, which seems to be doing everything it can to slow back and roll back net zero. And that's actually being mirrored across the world. Other political systems, commerce, and in corporate worlds, we're seeing not just a failure to deliver on previous pledges, but actually a rollback, a decrease in ambition. So when we should be going faster than ever, there seems to be indications we might even be slowing down. Okay, so finding our meaning of all that said, putting that to one side, what do we do about this? So I'm sure if you've been in this space for any time, you have struggled, maybe, to carry on, right? You don't want to engage with some of the news. It seems insensitive to what you do. You write your letters, you do your petitions, you go on your protest. I mean, who was at XR? Anyone been on XR? Right? The heady days, that little window in 2018 when we thought stuff might actually happen. How do we keep this up? And so these are some unsolicited bits of advice I'm going to dispense, right? The first thing is it needs to be created. right? You're not going to find this anywhere. It needs to be an active process creation. You need to think about what is that I can do to be some kind of contribution to making the world, and I know it sounds cliched, a better place. I don't need to really necessarily have to define a better place. Maybe that's going to come immediately after me, but we certainly don't want that place we're heading to, right, which is potential catastrophe. So the first thing, we are going to win, right? The age of fossil fuels is, no matter what lunatic in the White House wants to argue, is over, right? And the reason is essentially about pace and speed of this thing, the solar energy transition, right? And this is where we do actually have physics on our side. When you think of the enormous amounts of energy which strike the surface of the Earth from the sun, there is no way that any viable civilization is not going to transition to basically a solar-powered civilization. We already are solar-powered, right? Everything that you've just eaten was driven by the sun. It's our appropriation of primary productivity. Not just the electricity that might be generated by wind turbines, but all the energy is produced by the sun because it's fossilized sunlight, because it comes from fossil fuels. Those fossil fuels were produced by the capturing of photons from the sun hundreds of millions of years ago. What we need to do for the solar transition is just go directly to the source, right? And that is absolutely happening. That's being at the moment driven by China, and there's a whole bunch of reasons why we should be worried about that. But ultimately, over that long arc of human history, it is going to happen, right? At the same time, the concerns that maybe some people might have had around the population bomb, the population exploding at some point, we seem to have, at least in a global context, diffused that population bomb. The global average increase in population is slowing down. It's been slowing down since the 1970s. Countries are going through the demographic transitions. You might be reading things that we're not having enough babies, right? We need to have incentives to have more kids. The question at the moment we've got right now is where people are being born and what kind of exposure they're going to have to future environmental change. But this idea of overpopulation, I think we can now begin to feel a little bit more relaxed about. And this is the other thing about population. The 10% of the richest people in the world are responsible for about half of all the consumption-based emissions, right? We don't have a population problem, we've got a consumption problem, and that is something that we can do about. We can, for example, politely ask these richest 10% to maybe take their foot off the gas, or maybe we could implement changes, legislation, rules, incentives, perhaps even punishment, to make sure that they cannot undertake continued profligate consumption of fossil fuels and therefore disproportionately drive climate change. Okay, so first thing, stop doom scrolling, right? You've got to get off your phones more generally. I feel like I'm talking to my teenage sons, right? Get off your phone. These devices are designed to engage us in ways which are probably extremely unhealthy, and if it bleeds, it leads. You very rarely hear about a good news story just scrolling randomly through your phone. It doesn't really give you any agency because you are not the problem, right? It's important to understand, okay, probably some of us are in that 10% in terms of the world's richest population. You might not feel very rich, but certainly in a global perspective you are. It's not that so much you're the problem, it's the problem is the systems that we live within, right? And all systems change. This idea that there is nothing we can do about the systemic drivers of climate change is a dangerous fiction which also serves the interests of those who have every incentive to not change, right? I happen to have been involved in a film about that. So I forgot to bring the flyers. Director Paul told me to bring the flyers. I shouldn't have said that. I could have gotten away with it. I could have said I brought the flyers. But anyway, I haven't brought the flyers, but you can go to climate.film. Please visit climate.film, and it talks about how we might be able to undertake some of the systemic change that climate change now demands. About 10 years ago, we did another film called The Race is On, right? Secrets and Solutions of Climate Change. Well, we didn't win the race. We just have to acknowledge that the world is a different place. So we're now talking about some of the deeper systemic action that we now need to see. And these things do happen. If anybody's heard of the Overton window, this idea of what's kind of politically possible, it changes over time. It might not necessarily be very fast, but you can grab hold of it and you can try and drag it in directions that we need. So, for example, one of the things that system change looks at, system reboot, is this notion of assumption of continual economic growth. Maybe we need to relax some of those assumptions of continual economic growth in some places and maybe put more emphasis on how we distribute the goods and services that economies provide in order to make sure that everybody has decent lives. So it's just one way that we might be able to shift the window. So you can change systems. Sorry, right, okay, this is my students. One drop of water does not make an ocean, but an ocean is nothing more than drops of water. We are all individual drops, right? Individually, yes, we'll just be evaporated away, we won't make any difference. But collective action is absolutely crucial given that we need to undertake systemic change, right? So yes, some of us, I don't know, anyone involved in Fridays for Future? Anyone bunk off school on a Friday? I mean, I did. I was there. We've talked about Extinction Rebellion. People also talk about the suffragettes. And they're a really good example because they were undertaking political systemic change at a time when the societal attitude was that women shouldn't vote. Women don't vote. What a crazy idea, allowing women to vote, right? They undertook a persistent and at times even violent campaign in order to actually drag that Overton window, in order to force politicians, in order to force the case onto society. And there's a lot of interesting work about in order to undertake societal change, you need a relatively small fraction, maybe about 20%. If you have 20% of a population committed to some kind of action or change, just the fact they can continue that, eventually they win, right? But the thing about the suffragette movement is they have been romanticized, right? Compare them to Insulate Britain. Insulate Britain was a very polarizing social movement. What did they do? They sat in the road and they held up traffic. That's essentially what they did. That was their transgression. Or let's take Just Stop Oil. They've largely parked it now. They've kind of hung up their high-vis jackets, but they did a whole series of events where they disrupted sports events. Anybody recognize Eddie? So he's one of our alumni from the University of Exeter. Go Eddie. Extremely, at the time, extremely controversial. But when you think about what the suffragettes were doing, right, if anybody doesn't know the history of the suffragettes, they were involved in sabotage, they were blowing up post boxes, they were smashing windows randomly in high streets. My favourite is when they whipped Winston Churchill. That was, I can't remember her name, but one of the prominent suffragettes horse-whipped him as he was, they gained access to the King's coach, and I think they tried to abduct a number of politicians. They were not messing around, and at the time they were deeply, deeply unpopular. But the thing is, they won. Now, I'm not suggesting anybody does any of those things. I'm just saying that social change, systemic change, is difficult, and there is going to be significant resistance. But here's a good win, right? So a friend of mine, Adam Aaron, has been working at the University of California for years about getting that particular institution to undergo system change. And they've chased the bank out of campus. They are changing the curriculum. They really have made transformative action just by being in there and constantly making the case that the university needs to work better. Nearly done. Work collectively, right? This is my representation of why we can't have nice things. Here's Jeff Bezos buying Venice, and here's the rest of us. Basically, political systems are engineered in such a way that the 1%, the 10% have an enormous political lever. They have tremendous advantage. Yes, we need to put more people on the other side, but yes, we also need to think about where we can move that pivot, right? There is tremendous power in mass action. Join a group if you're not already, right? You're not alone, and don't try to reinvent the wheel. There are already people that are desperate for your efforts, for your engagement, maybe sometimes your money, right? There's transition networks. Some of you must already be involved in this. Donor economics, anyone? You all heard of that, right? There's a donor economics group in Exeter. We've had engagements, we've had projects, we've had Kate come and visit. We're doing citizens' assemblies through the university itself. And then, I think this might be near the end, walk the talk. I've been involved in trying to empower academics to do more useful things. We are changing the way that we're trying to travel in the university, and that involves undergraduate travel. If you do these things, people will take you more seriously if they ask you the kind of changes that you're taking. Oh, and also we've advised the university to ditch offsets because it's bullshit. Right. Use your privilege to find your ikigai, this idea that what you love, what you're good at, what the world needs, and what you can be paid for. We have the luxury, probably, because we can take time out in our lives and think about how we might be able to re-engineer some of the work that we're doing, and start today, right? Don't delay. There's absolutely no reason why you can't be asking questions like this. There is never, ever a moment when it's too late. And then respect your moral compass. You're doing some things and you know what's right, but money always has a habit of kind of skewing it around, right? We all need money, we need to pay the rent, but try and remember what is actually important to you. And finally, never give up. If nothing else, it will upset them that you actually are continuing to be the grit in the wheel. And collectively, together, we might not just stop the wheel, we might be able to drive it in an entirely new direction. Thank you very much.